Let's suppose we want to add two mixed numbers. For example, suppose we want to add 2 3/7 plus 19 2/7. Now, the first thing that might occur to us is to make these into improper fractions. And that is an option. But what's wrong with that idea? What's wrong with that idea is that in this example, that would require multiplying 7 times 19. In general, that's going to involve working with large numbers. So if we possibly can, we'd like to avoid that approach. Instead, let's think about what this 12 3/7 means. 12 3/7 means on the number line, go up to 12 and then another 3/7. In other words, the number 12 3/7 can be broken down as 12 plus 3/7. What's good about this? This lets us make the same kind of expanded form sort of move that we made to get our algorithm for adding whole numbers. We can say 12 3/7 plus 19 2/7 is, well, 12 plus 3/7 plus 19 plus 2/7. And then we can use the commutative and associative properties to say that's going to be 12 plus 19 plus 3/7 plus 2/7. Notice this only works because all of the operations are addition, which is commutative and associative. If we had other operations around, this move wouldn't work out the same way. So what this really means is we'll add the whole number part. 2 and 9 is 11. 1 and 1 and 1 is 3. Add the fraction part. 3/7 plus 2/7 is 5/7. And that will give us our sum. Now, just as when we were adding whole numbers, we started in the rightmost column, typically when we're adding mixed numbers, we're going to start in this new fraction place. So this gives us a procedure then for adding mixed numbers. First, we're going to add the fraction part. And when we do that, we need to make sure that the sum is a proper fraction. Why? Because the fraction part of a mixed number has to be a proper fraction. Once that's done, we'll add the whole number part. So if I wanted to add, for example, 242 6/13 plus 189 5/13, first I would add the fraction parts. 6/13 plus 5/13 is 11/13. Noting that 11/13 is a proper fraction, I'm still okay. And now I add the whole number part. 2 plus 9 is 11, 1 plus 4 is 5, and 8 is 13. 1 plus 2 is 3, and 1 is 4. I'm going to show you an example of this also where we have unlike fraction parts. Let's suppose we want to add 13 1/3 plus 43 1/6. We'll write our 13 1/3 plus 43 1/6. Now we need to write 1/3 and 1/6 with a common denominator. Multiples of 3, 3, 6, 9, 12. Multiples of 6, well, the very first one is 6. 6 will be our least common multiple. 1/6 will stay 1/6. 1/3. I want to get 6 for my denominator, so I need to multiply 3 times 2. I should also multiply 1 times 2. I'll get 2/6. 2/6 plus 1/6 is 3/6. I see that 1, this is a proper fraction, but also I can simplify this, right? This is 3 times 1 over 3 times 2 is 1/2. So the fraction part in my answer will be 1/2. 3 and 3 is 6. 1 and 4 is 5. I get 56 and 1/2 for my final answer. Now I'm going to give you one of these to try. Add 8 and 4/21 plus 5 and 9/14. Pause the video and try this now. Alright, I'll write these vertically. I'm going to write this number on top because I like to have more digits in my top number if I have a choice. I'm going to need a common multiple of 14 and 21. Multiples of 14, 14, 28, 42, 56, 70. Hopefully that'll be enough. Multiples of 21, 21 not on both lists. 42, there we go. So let's see. I'll multiply my 14 times 1, 2, 3. So I'll need to multiply my 9 times 3. I'll get 27 40-seconds. I'll need to multiply my 21 by 1, 2, which means I'll need to multiply my 4 times 2. I'll get 8 40-seconds, which means in my total, I should add 27 plus 8 off to the side. 8 and 7 is 15. 1 and 2 is 3. So I'll have 35 40-seconds in my total. Oh, but I see that 35 is 7 times 5, and 42 is 7 times 6. Canceling the common 7, I'll have 5/6 as the fraction part of my total. Then 5 and 8 is 13, 1 and 1 is 2. 8 and 4/21 plus 15 and 9/14 is 23 and 5/6.